Welcome to MADE EASY Prime. Myself Ram, and today we will discuss the effective stress and capillarity. So, in the effective stress and capillarity, suppose for example this is a particular problem. So first of all read the problem, then understand what that question is asking. Second step, what is that given data, and third step, algorithm, strategy of that particular question. So here you can see question, a dense silt layer of thickness 10 meter has the following properties: void ratio E 0.40, effective stress D10 10 micron, effective diameter D10 is 10 micron meter, capillarity constant 0.2 centimeter square, unit weight of solids 26.5 kilonewton per meter cube, groundwater table is 8 meter below the surface. First, the height of capillarity, draw the total stress, pore water and effective stress diagram, and determination of effective stress at 5 meter and 10 meter. So this is a particular problem, and in this problem that question is also asking the effective stress at the 5 meter and as well as 10 meter. Clear? So this is the problem. So first of all here we have to understand what is that concept of capillarity, because it is an important concept. So here first of all we will discuss the capillarity concept. So point is to be noted that water have some surface tension, every fluid have some surface tension, and depending on the surface tension and due to the adhesion and cohesion forces, there will be like formation of meniscus, and due to this meniscus there will be like surface tension, and that's why water will raise in these capillary tubes. Here you can see that diameter, that capillary tube which have less diameter will have high capillary raise. So this is the concept of that capillary raise, and now we have to understand in detail. So here suppose for example if we discuss the soil water first in the soil mass. So point is to be noted that there are different type of soil water. First is like free water, second like adsorbed water, third like capillary water, and fourth one is structure water. So now suppose for example this is a ground level, and below the ground level there is a what? Groundwater table. Some depth below this groundwater table will be there. This is what? Free water surface level. This is what? GWT. Now in this case, point is to be noted that below this GWT that water is what? Free. This is what? Free water or gravity water. This is also termed as gravity water, and all the laws of hydraulics is valid in this particular water. Point is to be noted that this water is like free. Pascal's law, Archimedes principle, all the laws are valid over here. This soil is saturated because voids are fully filled with the water, as well as there will be force of buoyancy due to this Archimedes principle, and that's why this soil mass is what? Submerged also. So this soil is what? Saturated and submerged. Saturated and submerged. Point is to be noted that property of surface tension, due to this property of surface tension of water, there will be some raise in the soil mass. So point is to be noted here also there are something like capillary tubes. Some capillary tubes. For example, if we consider this is what? This is the soil mass. This soil mass have some soil solids. These soil solids are what? Interconnecting voids, and now in these interconnecting voids there will be like formation of meniscus. Due to this meniscus, now that water will raise. Now point is to be noted that this raise in water takes place up to what? Takes place up to the extent when the surface tension force is equivalent to what? Weight of water. And due to this that water will raise up to some height. Now point is to be noted that interconnecting void size may be different. Somewhere it may be less size of interconnecting voids, and somewhere it may be more, and that's why somewhere this raise will be like up to more height, greater height, and somewhere it will be up to lesser height. Due to this raise in capillary, there are chances that a particular portion of a soil mass will be like fully saturated due to this capillary water. So this is like fully capillary saturation, and in this zone you can see that voids are partially filled with the water. So due to this capillary action, soil may be in partially saturation also. Point is to be noted here this water is rising. So now we have to understand the concept up to what extent this water will raise, up to which height this water will raise. So height of capillary tension we have to determine, and as well as what will be this pore water pressure in this particular capillary zone. You know very well that below this groundwater table, if this height is h, if this depth is h, so at this level that pore water pressure will be, tell me, Pore water pressure will be very good. So this will be what? Rho GH. It is compressive or tensile? Tell me. Obviously, it will be compressive in nature. So this pressure is like in compressive. And now we have to also determine the height of capillary rays as well as that pressure in this capillary zone. So now in this case, when we are taking a capillary tube, so we will understand this concept by a capillary tube. So here, suppose for example, we are inserting a piezometer. Okay. So this is a, suppose for example, piezometer in this particular groundwater table. Now when this piezometer is there, so you know very well that due to this adhesive and cohesive forces there will be formation of meniscus, and this meniscus will be something like what? Concave in the water, and it will be like convex in the mercury. When this concave meniscus will form, so you know very well that on this particular meniscus there will be surface tension force, and that surface tension force is, suppose for example, what? T. Now point is to be noted that suppose for example this angle is what? Alpha. So this surface tension Ts, we can say this Ts is acting like this at an angle of alpha. Now point is to be noted that if this is a capillary tube and now you can see that this tension is acting like this. This is what? Surface tension. So now this tension have two components. One is T cos alpha and another one is what? T sin alpha. Now you can see that this T sin alpha will act in all the directions, and when it will act in all the directions, so this T sin alpha will be cancelled out. But this upward component of this Ts, which is like T cos alpha, it is acting in the upward direction. So actually this tension is pulling this water against the gravity in upward direction. Am I right? So now in this case, you can see that upward force is acting, and that's why water will raise. Now chances are there that this upward जो tensile force है, this tensile pressure will not be balanced by this weight of water. If forces are like unbalanced, if this T is more, then water will raise further. So now in this case you can see that water will raise further. Tell me, when we are taking the surface tension, so here this T will be same or different? So obviously this T will be same. This is the property of water, and if temperature is constant, so this T will be same. Now this T cos alpha is acting in upward direction, and you can see this weight of water is acting in downward direction. Am I right? Now chances are there that this upward surface tension is not balanced by this weight, and if it is not balancing, then water will raise further. Now when it will raise further, so again there will be like T. Now chances are there that this weight of water which is acting in downward direction is not equivalent to this tension force, and that's why water will raise further. And now there will be a one particular moment when this upward tensile force will be equivalent to this weight of water. And now upward tensile force is equivalent to this weight of water. So now we can say that equilibrium has been reached. Forces are in equilibrium condition. Forces are balanced, and if forces are balanced, there will be no further raise in this capillary tube. So now hence we can say that this height of capillary is what? HC. This is height of capillary HC. Clear? Now point is to be noted that here if we want to determine this HC, so we can say that this SC, if we want to determine, so just we have to equate these forces. When we are equating these forces, so we can say water will raise, concept number 1 we can say. So there are many concepts in this capillary water. So concept 1, water will raise up to an extent when surface tension force is balanced by weight of water. Am I right? Weight of water. So now in this case we have to balance these two things. So first of all, upward direction, there is what? T cos alpha. So we can say that this T cos alpha is acting upward. But point is to be noted that when we are taking surface tension, so this surface tension is like surface tension is acting in upward direction, or this is what force per unit length. This is like Newton per meter. So if this is like force per unit length, then we have to multiply it by the length. So if the diameter of this tube is d, so then we can say that length of this water is something like what? Pi d. Length over which this force is acting is what? Pi d. Will be equivalent to weight of water. Now if you want to determine this weight of water, so this weight of water is equivalent to what? Volume into gamma w or rho g we can say. Volume will be equivalent to what? Area into height. Area into height into gamma w, am I right? Height is what? SC. Now when we are taking area, so we can say this is like what? Pi by 4 d square. Pi by 4 d square, pi by 4 d square into HC into gamma w. Am I right? Now hence we can say this d to d cancelled out, and hence this SC comes out to be 4t cos alpha divided by gamma w d. Now point is to be noted, this is what? HC. Now this SC can be written as SC max also. So SC max, so this value will be maximum and this cos alpha will be equals to 1. So when this alpha is equals to 0, we can say alpha is equals to 0, then we can say cos alpha is equals to 1, and hence we can say that this SC max will be equals to 4t upon gamma w d. Now this surface tension is something like constant for a particular water at particular temperature. Gamma w is also constant, 4 constant hai. So now hence we can say that this SC max at 20 degrees centigrade, at 20 degrees centigrade, when we put the values of this T and this gamma W, this comes out to be 0.293 divided by D centimeter, where this D is the size in centimeter. So this D is also in centimeter. So point is to be noted ki this is something like approximate height of capillary rays, which can be written as 0.29 or 0.3 divided by D. At 4 degree this is around 0.3 divided by D, or at 20 degree this is around 0.29 divided by D. D is in centimeter, or this SC max will be in centimeter. So by this way we can say that this height of capillary HC will be this. But now you have to understand this concept that this is what? Capillary tube of size D. This is capillary tube of size D. But when we are taking soil mass, so in this soil mass, it is not like a capillary tube of size D. It is what? It is interconnecting voids. So at the place of D in that formula, we have to take what? Size of these interconnecting voids. Now, if I am saying to you, okay, determine the size of this interconnecting void, so it is very difficult to determine. Am I right? So because it is very difficult to determine the size of this interconnecting voids, that's why there is some like approximation, and in this approximation we can say concept number 2 कि this D should be what? D should be size of interconnecting voids. Interconnecting voids, because it is not like capillary. And another thing is what? In the capillary, that water will raise in vertical direction also. But when we are taking interconnecting voids, so this interconnecting voids may be vertical, may be horizontal, may be vertical like this. And that's why here this D should be size of interconnecting voids, and that's why scientists gave some approximation. And this D can be assumed as 20% of effective size. Assume D as 20% of effective size. Effective size is what? D10. So now in this case, this is something like approximation. Sometimes when that questions are there, so sometimes question may say that this is something like 1/8 of effective size. Sometimes it may say 50% of effective size, so it depends upon the question. If nothing is mentioned, then you can take this D as 20% of D10. It means D is equal to D10 by 5, okay, or 0.2 D10. Now point is to be noted that this HC max is equivalent to what? SC max is equivalent to 4T upon gamma W D. This D is the size of interconnecting voids, which can be taken as D10 by 5, and hence we can say 4T upon gamma W D10 by 5, and hence we can say this HC max, in case of soil is around 20T upon gamma W D10. D10 is the size of effective size. Okay, 10% particles are finer than this particular size. So in this case, this is the first approach. Second approach is given by scientist Allen-Hazen, and there is another equation, that is what? Allen-Hazen equation. Scientist Allen-Hazen says that this HC max can be taken as C upon E D10. Can be taken as C upon E D10. Now point is to be noted that here this C is something like constant. This C is something like constant. Its value may be 0.1 to 0.5 centimeter square. So 0.1 to 0.5 centimeter square, that constant value. E you know is what? Void ratio. E is void ratio. D10 is the effective size in centimeter. And this answer will be in centimeter. Okay. So by this way also you can determine the height of capillary rays. So this is what? This is in case of soil, and that we determined in the previous slide. So this is something like in water, which have like a capillary tube of size D. Now point is to be noted, again we are coming back to this particular capillary rays. Now we are saying another concept. Understand, all the concepts are important. Now we can say that below this water table, this water is in hydrostatic condition. This is something like free water, and this pressure rho GH is what? In compressive nature. Now point is to be noted, here also this water is present, here also water is present, and if water is present, so this water will also have some pressure. So we have to determine this pressure also. So now how we will determine the pressure? So point is to be noted that when we are determining the pressure in this particular problem, so this is what? A height of capillary rays. Now this is like groundwater table. Now understand this concept that in this particular capillary tube, on this water, there are two forces. Which is acting on this particular water. First one, tell me. First one is what? Very good. First one is that surface tension. Second one is weight of water. Very good. So why this way we can say this is what? This is the water. Okay. And now on this water there are some pressure. So first of all you have to understand that there are two pressure. One is surface tension. Surface tension is acting in which direction? Upward direction. And this weight of water is acting in downward direction. Am I right? So hence we can say that there are two forces. And when we are determining these pressures, so we can say that first pressure is acting in the upward direction. Now this tension is like acting same everywhere, and that's why we can say that pressure which is acting in upward direction due to this surface tension pressure will remain constant, and this pressure is acting in vertical direction. So we can say this is like in vertical direction like this. Clear? Now point is to be noted that on this same water there is another pressure, and this pressure is what? Weight of water. Now when we are taking this weight, so tell me what is the weight over here? That is equal to 0. And when we move downward, so similarly when we move downward, so that weight of water will increase. So another pressure which is acting on this water is what? Weight. And now in this case, when we are taking weight, so this weight is 0 over here, and it will continuously increase like this. Am I right? So now we can say this is what? Weight of water. Tell me the direction of this weight of water. The direction of this weight of water will be downward. Very good. So now there are two pressures which are acting on this particular capillary water. One is surface tension force which is acting in upward direction, and another one is this weight of water which is acting in downward direction. Am I right? Now point is to be noted that there should be some sign convention. If you are taking compression as positive, then you have to take tension as negative. If you are taking downward as positive, then upward should be negative. Am I right? Now we have to determine the values of this pressure also. So you can see that pressure over here is what? 0 due to weight. Now if we are determining pressure due to this weight of water over here, so we are taking pressure. So understand this concept that pressure should be what? Force upon area. Force upon area. Force is what? Weight divided by area. Now weight of water when we are determining, so this will be like volume into gamma W. So we can say volume into gamma W is the weight. So when we are taking volume, so we can say pi by 4 d square into HC, volume into gamma W is the weight of water, divided by area. So area over which this weight is acting is like weight area of this capillary tube. So we can say this is what? Pi by 4 d square. Pi by 4 d square to pi by 4 d square cancel out, and this will be like HC gamma W. So here we can say that weight of water over here is 0, and here this pressure is equivalent to what? HC gamma W. Am I right? Now point is to be noted कि this capillary will raise up to the extent when the surface tension is equivalent to weight of water, and that's why if pressure over here is SC gamma W, then it is very obvious कि here also this pressure will be SC gamma W. And if here this pressure is SC gamma W, so here also this pressure will be SC gamma W. Now you can say, sir, why you are not taking tension into the picture? Because if we will take the tension into the picture, so unnecessary one unknown will be there. And you know very well that pressure is generally represented. Pressure is generally represented in the form of height, and that's why here we are taking SC gamma W. Now point is to be noted. Now there are two pressure, one is acting upward and one is acting downward. Now we are determining the resultant of these two. So again I also told you that sign convention. So if compression is positive, then tension should be negative, and if upward is negative, then downward should be positive. So here, because we are taking compression as positive, downward as positive, so that's why upward or tension should be taken as negative. So in this case, we are determining the resultant pressure over here. So we can say that this is like what? Height, depth, and now in this case, that resultant of these two we are determining. So we can say कि here SC gamma W upward at this level, SC gamma W upward, 0 downward. And now due to this we can say that resultant is SC gamma W which is acting in upward direction, and upward is taken as negative. So we can say कि here this pressure is what? Minus SC gamma W. Minus SC gamma W, this pressure is there. Now point is to be noted कि when we move downward, so this is like acting upward, this is acting downward, this is increasing, this is constant. So resultant of these two will be like decrease, and now hence we can say here this is minus SC gamma W, and this value will be like this. Sorry. And at the level of free water surface level, groundwater table, SC gamma W upward, SC gamma W downward, and that's why that resultant value will be 0 in this case. Okay, this entire portion is in negative. Why it is in negative? Because that water is in tension. So this is something like tensile pressure. Now point is to be noted that below this groundwater table, that water is in like compression, and if you are determining the pressure at the depth of H, so this pressure will be how much? H gamma W, positive or negative? Positive. This is what? Compressive pressure. So here it will be like H gamma W. So now in this case you have to understand that when that pressure is there, capillary tension is there, so due to this capillary tension, pore water pressure will be negative at the top, and at the top of meniscus this will be what? Minus SC gamma W. At the top of meniscus it will be minus SC gamma W. This reduces to 0 at free water surface level, and below the free water surface level this is H gamma W, which is what? Compressive in nature. So remember this thing. So this is what? Important concept. This is what? Pore water pressure in the capillary zone. ठीक है? बेटा एक बार स्टॉप करना, ठंड हो गई यार. Now point is to be noted कि here this capillary tension is minus SC gamma W, this water is in tension. So because this water is in tension, so tell me, will this water be applied any buoyancy on the water? Buoyancy on the soil solid, sorry. So will it be applied any buoyancy? Obviously no. Because this water is in tension, or because it is like in tension, so it will not apply any buoyancy, and that's why due to this water soil will be in saturated condition only. Here below the water table soil is saturated as well as submerged, because voids are fully filled with the water, as well as that buoyancy is also applicable. So it is also important concept. Below the water table soil is saturated and submerged, and in this capillary zone soil is only saturated, not submerged. It means that soil which is submerged will also be in saturated, but it is not necessary that soil is in saturated condition will always be in submerged condition. Okay. Now point is to be noted. So this is the concept. Again, so this will be used in the effective stress pore water pressure. Now I am coming back to the problem. So in the problem, question is saying like this: E is 0.4, gamma is 26.5, D10 is 10 micron meter, and after that it is determining the total stress, pore water, effective stress and all. So point is to be noted that when we are like solving this particular problem, so this formula Allen has an equation will be used, because you can see C is given, E is given, D10 is given. So first part, in the first part we can say part 1. So question is saying the height of capillary rays, so SC max. So point is to be noted that here SC max will be determined as C by E D10, because according to given data this formula is applicable. So C upon E D10 will be the formula. Now point is to be noted that in this case C is given as 0.2 centimeter square, E is given as 0.4, and D10 is 10 micron meter. It means 10 into 10 to the power minus 6 meter. Clear? And hence we can say this is something like 10 into 10 to the power minus 4 centimeter, or 10 to the power minus 3 centimeter. So hence we can say this is like 10 to the power minus 3 centimeter. When we are solving this particular problem, so we can say this C 0.2, determine it, divided by 0.4, so it comes out to be 500 centimeter, and this 500 centimeter will be like what? 5 meter. So we can say that height of capillary rays in this particular problem is what? 5 meter. Clear? Now question is saying ki draw the total stress, pore water and effective stress diagram. So when we are solving this total stress, effective stress and pore water pressure diagrams, so we have to do the calculations, and accordingly we have to solve.